Hello, welcome to the one more important session on the course Irrigation and Bridge Drawing. In this session, we are going to solve waste wear with water cushion. Okay, I think another 45 to 50 minutes you will learn one more new drawing. Let us start step by step procedure how to draw the waste wear with water cushion. Following are the details of tank wear with water cushion. Catchment area 2.36 square kilometer. Rivis constant 8.75. Find the maximum discharge by using the Rivis formula. We have to find out the maximum discharge. Find the length of the waste wear with the head of 0.7 meter. You should calculate the length of the waste wear. This may carry 10 marks in the examination. Find the length of the waste wear with the head of 0.7 meter. Top bund level 36 meter. TBL full tank level 34.5. Maximum water level 35.2. Ground level 32.0. Upstream slope, downstream slope, top width of the bund. These are the bund details given. In bund, one portion may be the waste wear. Next, body wall details. Top width of the body wall 1 meter, bottom width of the body wall 2 meter, top level of the foundation concrete is 31.0, bottom level of the foundation concrete 30.4. That means depth of concrete is 0.6. And then depth of the water cushion. Water cushion is given 1 meter. This depth is the where whatever the energy, falling water energy is dissipated, so that the erosion of bed may not take place, because it is an enormous energy which will erode the portion when it is passing through the waste wear above the FTL. And then horizontal apron is given with a slope 1:4. Horizontal apron is provided at the 33.00 RL 4 meter. Top width of the abutment is given 0.5. Bottom width is 2.0 meter. The batter of 1:8 is provided on the water side. Here water side, it is not a vertical, it is inclined. Previous problem what we solved, stepped apron, there we assumed the water side as a vertical. Return wing walls details are given. Top width at RL 34.5, and then bottom width it is not 2 meter, it is take as an 1.2 meter. 1.2 meter. Top width of return wing wall on downstream side at RL is 33.0 meter is 1.2. That is both side we are taking the 1.2 meter. I think it is typing mistake. 1.2 meter. A batter of 1:8 is provided on water side. Here also water side we have to take the batter of 1:8. Draw to a scale 1:100. Half plan at top and half plan at foundation. Cross section across the body wall. Half front elevation and half sectional elevation. These are the three views asked in the examination. Okay, this you write down as a 1.2 meter. Before drawing the sketch, you should note down these details. So that you will easily understand whatever the component I am explaining, and whatever the RL or dimensioning I am showing on the drawing. Design length of waste weir for given catchment area. We can calculate by using the Q is equal to 2/3 CD LH root 2GH, or 2/3 CD L root 2G into H to the power of 3/2. Or we can use the Francis formula. If in examination they ask to calculate by using the Francis formula, then you should use Francis formula. Here catchment area is given 2.36 square kilometer. Discharge using the Ravi's formula, Q is equal to CA to the power of 2/3. Here C is given 8.75, area is 2.36. You substitute these values, you will get 15.54 cubic meter per second, cumex, as the discharge. Then here you assume the coefficient of discharge as a 0.6, head over the weir 0.7, MWL minus FTL, or in problem it is given 0.7, G value 9.81. Substitute all the values in this formula. This is 3.7. If you simplify root 2GH, you will get 3.7. 0.7 is the head, 0.6 CD, and then discharge we are calculated here 15.54. By cross multiplication we will get length of the weir as 15 meter. For this calculation you may get 5 to 10 marks. First, draw horizontal line showing ground level 32.0. Then mark TBL 36.00 by drawing horizontal line at a distance of 36 minus 32.0 is equal to 4 meter. This distance 4 meter. Draw inclined line as shown in figure 1.5:1, that is 1.5 horizontal to 1 vertical. Mark top width 2 meter at TBL. And draw downstream slope 2:1, 2 horizontal to 1 vertical. This completes the cross section of bund. What we are going to draw here is the cross sectional along the body wall. Mark FTL 34.5 given in the problem, MWL 35.2 by drawing a horizontal line as shown here. One horizontal line, another horizontal line. Also mark hard rock level 30.40 and top of bund, that is the top of bed concrete level 31.00. Next mark the center line from the top of bund. At FTL level, draw top width of body wall as 1.0 meter, that is 0.5 meter from this line, left side as well as right side, so that body wall exactly fits the center of bund. Mark 2 meter at RL 31.00 and join bottom points by inclined line. Complete the body wall foundation with offsets of 0.2 meter. This is the offset. This is bed concrete of body wall. Fine. Cross section of body wall is completed. Now draw abutment line. This is abutment which retains the earth. When we draw plan and longitudinal section, abutment portion can be viewed clearly. Complete naming of body wall. Mark 4 meter distance, which is the horizontal portion of solid apron for water cushion at foundation level. Extend concrete bed lines up to 4 meter. Mark water cushion depth 1 meter given in the problem. It matches with the ground level or bed level at downstream side. Now it is time to complete water cushion portion by drawing 1 in 4, that is 4 horizontal to 1 vertical in upstream upward direction. Touching the upper line of concrete apron at bed level. Up to this point. Thickness of solid apron 0.4, because 31 minus 0.4, that is not 0.4, that is 0.6. 0.6. You can observe 31 minus 30.4, 0.6 meter is the thickness of this solid apron. Solid apron 0.6 meter thick. Label water cushion part. In this portion always still water exists, which dissipate the energy of falling water from upstream side above the FTL. Now beyond the solid apron, draw cut-off wall of 0.5 meter thick, and depth can be extended up to hard rock level with the concrete bed of 0.6. Label the cut-off wall portion with proper dimensions. Beyond the cut-off wall, show grouted apron of 2.5 meter length and 0.3 meter thick. If details of grouted apron not given, it should be assumed. Show talus for a depth of 0.6 meter and thickness equal to the grouted apron. This is the talus. This is grouted apron. Label grouted apron. Mark downstream side wing wall at RL 33.00 and draw horizontal line up to toe of downstream bund slope. Draw end of splayed wing wall, return wing wall with a batter of 1 in 6. This end of splayed wing wall, draw this batter 1 in 6 or 1 in 8. If it is in problem, it is given 1 in 8. You can take 1 in 8. Show 1:1 side slopes of guide bund on sides of downstream stream flow, which can be assumed. This is the guide bund. This is actually guide bund, guide banks, not what we will call. That is in the form of a bund, which will allow the stream to flow in proper direction. That you can assume. Show rough tone pitching. This is this one, rough tone pitching for side slopes. Now let us draw upstream wing wall. Mark RL 34.80 and draw horizontal line up to the end of earthen bund. We can leave certain distance so that the balance portion can be protected by stone pitching, and also this portion of return wall embedded in the earth on both the sides, this side as well as another side, which protect the edge of wing wall from water current and gives the stability. That is why we stopped the wing wall up to this portion only, and this is the batter given 1 in 8. That is like this, 8, 1. You can draw. Has the portion of cross section of body wall indicating stone masonry and bed concrete with a standard pattern, concrete pattern. This completes the cross section of wear through body wall. This is the hatching. This is the hatching. Okay, this completes one portion of your drawing. Let us start drawing half plane at bottom first. For this, project bottom width of body wall at foundation level, that is 2 meter, and also concrete offset beyond the edge of body wall, like this. at foundation level, because we are drawing half plane at bottom. Draw a sprayed portion of upstream wing wall and downstream wing wall, that is 3 horizontal to 1 vertical on upstream side and 5 horizontal to 1 vertical on downstream side given in the problem. Wing wall should be extended up to these 2 points. These are the 2 wing walls. This is upstream side, this is downstream side. Bottom width of wing wall can be assumed by applying thumb rules, that is 0.4 h, but in this problem it is given as 1.2 meter. You can assume this written wall length as a 2.0 meter. Now mark bottom width of abutment 2 meter by drawing horizontal line. From here to here it is abutment. Draw inclined line of length 1.2 meter at 90 degree to the sloping line. And similarly draw one more inclined line from this point equal to 2 meter, which represents the bottom width of abutment. Like this. Join these 2 inclined lines. Similarly repeat the procedure at downstream side also. Join 2 inclined lines. Now extend downstream side abutment line which meets inclined line at this point. Similarly extend abutment on upstream side which will meet at this point. Then extend return walls line on both sides. Upstream as well as downstream, which meets the inclined line at these points. Finally darken only these lines, only where it meets this point and this point, and this is the horizontal line of abutment. And remove construction lines. That is, this is the inclined line, this is one more inclined line, your abutment line is like this, and your return wall line is like this, your return wall line is like this. That means you have to catch these points only where it meets. Then you have to darken these lines only. This line, this is, this is, this is, this is. Balance these extended lines you have to remove. All these extended lines you have to remove. Finally, your abutment and wing wall shape will be like this. The junction of abutment and wing wall we maintain 2 meter. This is the junction, we maintained 2 meter. This junction is the weakest point which may fail due to earth pressure. Hence, care should be taken to draw this portion properly. Mark top width of abutment and wing wall by dotted lines. This is abutment, this is wing wall, that is equal to 0.5 meter. These dotted lines are called hidden lines. Since top width is not visible in present view because it is half plane at the bottom, then this portion is a batter of 1 in 8. That means this width should be what is the given batter on water side. This is the water side. This side its batter is 1 in 8. This is the water side. Here batter is 1 in 8. If we take total width this is 1.2 meter. 1.2 meter. Okay, it is dimensioning mistake. 1.2 meter. If we take 1.2 meter. In this 1.2 meter, some portion of batter will be here 1 in 8 batter. Balance width will be on earth side. Okay, how to calculate this? Here, this is the width 1. This you take 1.2 meter. Same 1.2 meter this side also. Then you can have a drawing here. You can observe this is the 34.8 is the upstream side wing wall level, and this is the top of the concrete bed level. If you minus 34.8 and 31, you will get height 3.8. 3.8 is the total height of the wing wall. If we give batter 1 in 8 on water side, 1 divided by 8 into 3.8. Height is height into batter. We will get 0.48 as the width of this portion. If its total width is 1.2, if you minus 0.48 and 0.5, 0.22 will be the batter on the earth side. That is, this width will be 0.22. This is 0.48. Center width is 0.5. Like that we have to show when batter is given. That means we are taking this gap, this portion is 0.48. Another one details I have shown here. This is 0.35. When we see at the ground level from the half plane at the top, when we see from the top, then we cannot see this portion. We will see ground level portion. There it will be 0.35. That means when we are drawing this side portion, then we have to take this width as a 0.35. Fine. Similarly, for abutment portion, this is the abutment portion. Abutment portion top level is 36, TBL level abutment is constructed up to TBL. Bottom level is 31, same. 31 minus 36 is 5 meter is the height of the abutment. 5 into 1 by 8 is 0.63. This is the 0.63. This portion is 0.63. This balance portion is 0.87 plus 0.5 top width. If you add all together, it is 2 meter. Okay. Therefore, we have to take here 0.63, here 0.48. That line we have to draw dotted line. From there, you can give a offset of 0.5. You will get this line. Okay, that means here it is, we have to maintain the width. Similarly, this side also, downstream side also, you have to maintain 0.63 here. This portion 0.48. Then you can join this line and finish this line, and take an offset 0.5. Take an offset 0.5 and complete this drawing. Exactly you have to do like this. Otherwise, if you don't have time, you calculate. You don't draw this sketch and all. You can directly you can calculate by knowing the difference in RL, top of the wing wall level and top of the abutment level and hard rock level. Multiply with 1 in 8, whatever the battery are assumed or given, you will get this projection width. Here also, when we see for the abutment from this level, this from the top up to ground level, that width will be 0.5. When we are drawing a half plane at top, we will take this width as a 0.5. This is the final half plane at top. Draw the top width of the body wall with the hidden lines because it is not visible. Bottom width is 2 meter, which is visible. Whatever the details which is not visible, that should be shown by hidden lines. Mark solid apron lines and cut-off wall lines along with concrete offset. This solid apron and then this concrete projection line. This completes the half planet bottom. Hatching can be done after completing half planet bottom. Draw cut lines to draw half planet top. These are the cut lines so that we can show the half planet bottom. Project edges of earthen bund, wing wall and top width of the bund. Top width. And draw dark lines indicating top width of bund. Show cut lines so that curtail the length of the bund. Length of the bund may be extended further also. That is why we curtail the length of the bund here, depending upon the availability of space in the drawing sheet. Then erase projection lines. Again, draw projection lines of body wall above the ground level, showing top width of the body wall as well as bottom width of the body wall at ground level, which can be seen while view from top. Here, this we can see that has been projected here, not this point, this point, this point here, top width portion. The top width projected. The top width is already here, hidden line is available. That same you can project this side. Okay, fine. Remove projected lines. Again, you have to remove all these projected lines. Now draw splayed wing wall as per the splay 1 in 3 and 1 in 5 upstream side and downstream side respectively. Extend the splay line up to the projected line from bottom view. Okay, you will stop wing wall same place where we are stopped in the top view, bottom view, sorry. Now mark 0.35 meter here, where this portion, because we have done the calculation previous slide, 0.35 meter here and 0.5 meter in this portion, which is width of wing wall and abutment due to batter 1 in 8 given on water side, which we discussed in the previous slide. Same drawing is reproduced here. This top width and all we reproduced here. This width only little bit lesser compared to here in this portion. Join these lines and also mark little bit groove, which indicates the body wall embedded into the abutment. This groove, we are giving little bit groove. This portion of body wall seen from top and this portion of the body wall and wing wall having top width 0.5. Fine, these are all 0.5, this portion and this also. Show length of the weir. From this point to this point is the length of the weir. Show rough stone revetment for balanced portion of earthen bund. Show sloping lines of earthen bund 1.5:1 on upstream side. Show sloping lines of earthen bund 2:1 on downstream side. Draw vertical lines at 4 meter and edge of cutoff wall indicating solid apron. Now draw grouted apron. Grouted apron portion at ground level, length equal to 2.5 meter, which has been shown in the cross section of the waste weir. Show top width and side slopes of guide bank and pitching to the side slope. This is top width, you can assume. Side slopes of guide bank which will guide the water to flow. This completes the half plane at bottom. Now it is time to draw half front elevation and half sectional elevation. For this, first draw cut lines to show both views. Draw FTL, top of the concrete level and bottom of the bed concrete level, that is hard rock level. Project top width at TBL level 36.00 and bottom width of the abutment from top view. This is the abutment bottom width. Then top width of the abutment. This is the top width of the abutment. Top width of the abutment should be shown at the 36.00. Bottom width at the 31.00. Project these lines. Join top width with bottom width. This portion is the body wall. Abutment near the body wall shown as a hidden line. Since body wall embedded inside the abutment are both monolithically constructed, that is why we have shown this portion as hidden line. Finish the abutment portion by joining these 2 points also. You can observe this is the 2 meter, because we are projected from here to here, definitely it will be 2 meter. Of course, water phase, this is the water phase, that is why this may be 1/8 slope. Automatically we will get 1/8 slope because we are calculated here this portion. Complete sectional elevation by drawing the concrete bed of 0.6 meter thick. This 0.6 meter thick concrete bed, complete this portion. We were cutting this portion, cutting here and then viewing here. This is the view what we are observing. Okay, if we cut this portion, we can see like this. Then we are viewing directly here. That is why it is known as a elevation, front elevation. Or sometimes we can call longitudinal elevation, longitudinal section. Draw one more cut line to draw half front elevation. Now draw ground level 32.00 and FTL 34.5. Again draw TBL 36.00 and downstream side wing wall RL 33.00. Project bottom width of the abutment or wing wall at the junction of wing wall and abutment up to ground level. That we are projecting here up to here. Project top width of the wing wall up to TBL. This you can project here this point. Also project the top width of the wing wall near the return wall up to 33.00 level. This top width up to 33.00 level and bottom width up to ground level. This bottom width here, this up to ground level. We are concentrating only what we can see from the top, not this side. This side it is filled in the earth. That is why we are only projecting the water side and top level, top whatever we are observing. Join all these lines, whatever you are projected this point, and join these lines. And then join from here to here one inclined line. That is better what we can observe. This is the overall picture what you can observe. Remove all the projected lines. Then join whatever here your projected line, you join from this point to this point. Show guide bund portion by giving in side slopes 1:1. This is the guide bund. This is optional. It is not given in the details. Just we are assuming and drawing the details. This portion can be projected here. Complete drawing by drawing the sloping lines of earthen bund, which is slope of 2:1. You have to mention here 2:1 slope that we can observe when we look in this direction. This completes the half front elevation also. That means almost all the three views has been completed. Only balance is hatching of the cross-sectional views or cross-sectional portions. These are all cut portions. This is also cut portion. and this concrete portion, then okay, here and all concrete we have to fill, and here and all we have to fill the concrete. See, hatched all the portions. Complete the drawing by hatching all the sectional drawings as per the material used. This is the overall sketch of the waste wear with water cushion. Okay, take the snapshot of this and start drawing in your drawing sheet. Fine, my dear friends and students, hopefully you are all getting an idea of irrigation drawing. In this session, around 50 to 51 minutes, you have got the clear idea about how to draw the waste wear with water cushion. This I am very happy to deliver this lecture series in videography, so that as you will also use this our video and this lecture series what I am posting in YouTube. Please subscribe our YouTube channel so that you will get immediately updates whatever the video I am uploading. You spend some 50 to 60 minutes, you can get in some ideas related to the civil engineering subjects. Thank you for viewing. Thank you very much. We will meet in next section, bridge drawing. Thank you.